Today, we're going to look at a new feature in RTC version 603, support for building HFS files. The idea here is to give you the ability to implement a portion of your dependency build in an Ant build file that is entirely owned and controlled by you. Your build file completely manages its own inputs and outputs and can perform whatever tasks needed in your custom build. EE's dependency build will invoke your build file as needed when changes in your HFS source are detected. Broadly speaking, setting up HFS build involves a few steps. First, let's sketch in our HFS source. We'll create a project, and for now just populate it with our build file. Just to get things working, our build file will initially be trivial. It's just going to echo a hard-coded string. Later, we'll show a more realistic example of a build file. Next, we'll configure dependency build so that our build file is invoked when our HFS source changes. This involves a few small steps. We create a new translator associated with our build file. This is also where we might define any outputs produced by our build file, something we'll demonstrate later in this video. We then associate that translator with a language definition. Here, we're just using a new one. This language definition is then linked to our HFS source project. The only thing left to do is to enable HFS builds on our build definition simply by clicking on the checkbox in our build definition and specifying the HFS output directory. With this configuration complete, dependency build will automatically invoke our build file now whenever anything changes in our HFS source project. So let's check out the results of a team build using this configuration. The most obvious thing is that if you're familiar with conventional dependency builds, the report looks like you might expect. It shows that changes were detected in our HFS source project, it lists the results from our build script, and any outputs are also accessible from here. Now that we have a basic setup, let's update the script to actually build stuff. Here, we're illustrating a use case in which we have a script that compiles some C language source. If we did a build now and then logged into USS, we'd see this zip file in our HFS outputs directory. But we can do better than that by telling dependency build to expect this output from our build file. In this case, the actual name of the zip file will be returned from our build file using a property called zip name. That property will contain the name of the actual file produced. If we build again, we can see that the build report now lists this file as an output. Another interesting step that we can add to our build file is uploading the zip file produced to the build result. This is done via the Build Toolkit's Publish task, and just requires this little snippet of code here. In subsequent builds, our build file's output will now be available in the Downloads tab of the build result. Now that we've set up our build, let's keep it in sync with a dev test hierarchy. For HFS build, promotion works pretty much as you'd expect. Here, we've set up a promotion build, and as a result, when we promote from dev, any HFS outputs will also be copied into our target build using its HFS output directory as the destination. Turning to packaging, it also works as you might expect. Here, I've created a packaging definition related to our HFS build, and as a result, any packaging we do will now include the build's HFS outputs. Similarly, deployment also supports HFS, meaning that HFS outputs are included. This concludes our introduction to HFS builds. Since they're so flexible, this is potentially a rather broad topic, and we've only illustrated the basic usage. For more information, consult our wiki at the website shown for more details. Thank you.